Statistics is the area of math where we collect data, we organize the data, and we analyze the data. So today we're only going to be taking a look at how we can organize the data. Now there are two different types of data. We have categorical data, which is about categories, and we have numerical data, which really deals with numbers. So let's take a look at the categorical data. That's usually the data displays that we use when we're really, really young. And the first one is called the bar graphs. And so a bar graph takes some categories of information. So say we wanted to know our favorite fruit juices. Well, we could classify them into the red juices or the blue juices. Those are our categories. Notice no numbers are being used for the categories. Now there are numbers on the graph, but it's only on one of the axes. It's on this vertical axis here. So you are going to have some numbers, but as long as you have words or categories going on, that would be categorical data. The second kind of categorical data display we use often is it's the circle graph. The reason why we say that is because on the circle graph we have these categories of information that are just divided up into pieces on the graph. So if we wanted to take a look at the fruits that people like, well, we could have apples, oranges, pears, or melons. Now, we do add some numbers to it because we want to know the percentages of that, but really we're just taking a look at those categories. Now, there are a lot of advantages and disadvantages between them. The advantages, they're really easy to read. The disadvantages, especially if we take a look at the circle graphs, is we don't know the exact number of people that actually asked or responded to that prompt with that fruit. We just know the percentage. So those are kind of some of the disadvantages for that. Our probably more important graphs or data displays that we use, those are the numerical, and usually we start to see those once we're getting into the upper grades with that. So if we're taking a look at numerical data displays, we have a whole bunch of them. So we have line graphs, we have scatter plots, histograms, box and whisker plots, and stem and leaf plots. They all look a little different, but they do have some things that are in common. So if you take a look at what they have in common is they really have a lot of numbers to them. If I take a look at both of these axes, look at your line graph, look at your scatter plot, look at your histogram, we have numbers on both of the axes. And so I see a number line going left to right on the x-axis. I see a number line going top to bottom on the y-axis, and that's part of the reason why it's one of the numerical data displays. Now the line graph literally creates a line. It's over time that we're looking at, and we can see specific points of what the data actually was. So if we were looking at the temperatures, and this was day 1, day 2, day 3, we can see exactly what the temperature was. That is an advantage to that. Now scatter plots and line graphs are almost the same thing. The difference between the two is a line graph, we can connect each piece of data directly. A scatter plot, our data is not really easy to connect, and so our job is to really get this line of best fit, and we're trying to get equal number of pieces above the line, equal number of pieces below the line, and it allows us to really make predictions or show trends with data. Now, our histogram looks an awful lot like a bar graph, but it is not a bar graph, because what we're doing with the histogram is we're sorting data. These are like our bins. Now notice we have a number line here and a number line there. That's part of the reason why it's a numerical display. And when I'm taking a look at the height of the bars, it's showing me how many pieces of data fell into that interval. So between 0 and 10, I had 2 pieces of data fall there. And between 10 and 20, I had 5 pieces of data. So we're just sorting that data. But that's one of the numerical data displays we have. Now our box and whisker plot, what we like about that is it actually is dealing with 5 specific statistical points, and we're really looking at the median. So when we take a look here, we have a number line that we're comparing it to, and we have 5 different points of median that we're looking at. So it is still a numerical display. Now our stem and leaf plot also deals with just our data. We're sorting the data numbers that came in, and we're sorting them into groups based off their place value position. So I know that my stem, it's my tens place. So that really represents all the numbers in the 20s, all the numbers in the 30s, all the numbers in the 40s. And the way I know how to read this is I look at my key, and so I see 2, line 2 would actually be 22. So I know that I had a data piece that was 22, a data piece that was 26, a data piece that was 27. So it doesn't really matter the data display I choose. Certainly certain data displays lend themselves better to different types of organization of the data. But definitely I could make a choice between any of these, and that would probably show my data in a really efficient way. Now, when we go and take a look at graphs, we also have to think, is the graph telling us the truth? So there certainly are misleading graphs out there, and it's our job to kind of pick up on that analysis of statistics to think, is the graph really representing the data correctly? Now, one way that they can mislead us is by messing with our vertical axis. And what we think about is something called a broken interval. We know that all intervals should be going up in equal intervals. So if I were going by twos, it'd be 0, 2, 4, 6, 8. Well, a broken interval, I start at 0, but notice I have no data between 0 and my next number, which is 81,000. But then the next number up is 82,000. And when I look at my bars, it looks like this bar is half the size of this bar. But in reality, it's only 1,000 away. So that is one way that this broken interval allowed us to think something that really wasn't happening unless we analyzed it. So we always look at the intervals to see, do they go up by a constant interval? Now sometimes they seem like they're going up by a constant, but you have to look a little further. So here I have an uneven interval. I have 0, then 1, then 2. So in my mind, we're going up by ones. But then it goes to 4. And if I continued on, it goes to 8, then to 16. Well, notice my interval changed as we went up. You can't do that when you're making graphs. And so that would be a way that we could do misleading graphs. Another place for misleading graphs, it's our circle graphs. So when we take a look at our circle graphs, we know a circle graph represents 100% of all the data. Well, number one, we got to take a look at the actual percentages. Do they add up to 100%? So if I look at this, it looks like I have 4 equal sections, and I have 25%, 25%, 25%, but then they only wrote 20%. When I add that up, that's only 95% of the data. That would be a misleading graph. Another thing they'll frequently do with circle graphs is they make the size of the wedges incorrectly. So they gave me half the circle is colored, but the percentage it represents is only 25%. So they misled me because the size of the wedge does not equal the actual percentage of it. Now there's a lot of ways that you can use misleading graphs, and it's really done to sway people's opinions to a direction whoever made the graph wanted them to think. So you absolutely have to be analytical when you're making your graphs and also when you're analyzing graphs. So really the organization of graphs is important, and there's a lot of different ways you can do it. Mostly we will be working with numerical data at this point, or numerical data displays, because we're a little bit more advanced with that. But I want you to read the questions carefully, and I want you to think what kind of display would probably be the best sort of display in order to show the data that I've collected. So good luck. I know you'll do well.